So I'm in my backyard with some ducks and a pond to see if we can learn about the differences between distance and time properties when it comes to a wave. To create waves, we need a disturbance, which I'm going to introduce by throwing in a rock. Now, as I throw in the rock, watch what happens. To find amplitude, we need to look at the line pointing at where the duck is sitting, that is our midline, and then the second line is pointing at the peak of the wave. If we compare the distance in height between the midline and the peak of the wave, we have our amplitude. For wavelength, we look at the peak of the first wave, as shown by the arrows, and the peak of the second wave, shown by the other arrow. And then we would measure the distance between the two, and we have our wavelength. We see waves spread out, and the ducks rise and bob just like we were talking about in your lesson. In looking for the wave speed or velocity of the wave, we'd look at distance and time. So we would look at where the wave peak starts and how far it went compared to how long it took to get there. Distance over time. Period can easily be found by looking at the water just below the duck and counting the amount of time between the first wave peak and the second wave peak passing that point. Finally, repeating the same clip for frequency, if we look at that point just below the duck and set a timer for 1 second, if we count the number of waves that pass by in that 1 second, we have the frequency.